Now we'll see what is the definition of heat engine and then the examples of the heat engine. So heat engine is nothing but what? It is a thermodynamic device operating in a cyclic process and produces work energy from heat energy. So input is heat energy and output is work energy. For example, petrol engine which is working on a standard Otto cycle, it develops the motion of the vehicle or rotation of the crankshaft by reciprocating motion of the piston, which is obtained by burning or by combustion of the fuel, that is petrol, inside the engine. Similarly, high pressure, high temperature gases, they are allowed to expand in the gas turbine and they develop the power. So that is in the case of the Breton cycle. Then steam power plant, which is working on the Rankine cycle. These are the examples of the heat engine. Now, the thermal efficiency of the heat engine is nothing but what? It is output divided by input. So it is the ratio of net work done to the heat supplied. For example, in case of Carnot engine working between the temperature limits of T1 and T2, where T1 is greater than T2, efficiency is given by 1 minus T2 by T1. For example, petrol engine working on Otto cycle, efficiency is given by 1 minus 1 upon R raised to gamma minus 1, where R is the compression ratio and gamma is the adiabatic index. For air, it is 1.4. Now, refrigerator is defined as, so you can see it is a device which is operating in a cyclic process. It transfers heat from sink, correct? So it transfers the heat from body at lower temperature to the body at higher temperature with the help of external work. So it is used to maintain the temperature of the sink or a closed space below the atmospheric temperature, and its performance is measured using coefficient of the term which is known as coefficient of performance. Likewise, in case of the heat engine, we are measuring the performance of the heat engine by using efficiency. In case of a refrigerator, we are measuring its performance with the help of the term which is known as coefficient of performance. And the refrigerating effect or cooling effect or heat that is absorbed, it is measured in terms of ton of refrigeration, that is known as TR. And the value of 1 ton of refrigeration is 3.517 kilojoule per second. That is, in 1 second, the heat that is absorbed by the substances is 3.517 kilojoule. So for example, if you consider our domestic refrigerator, and if it is of 1 TR machine, then in 1 second it absorbs the heat from your foods, from your milk, etc., the amount equal to 3.517 kilojoule. If it is a 2 TR machine, 2 ton machine, then it will absorb the energy equal to 2 times 3.517 in 1 second. So mathematical expressions are, in case of the coefficient of performance for the refrigerator, it is refrigerating effect that is produced divided by work supplied. Refrigerating effect is Q2 and work supplied is Q1 minus Q2, where Q1 is known as, Q1 is heat rejected in kilojoule per second and Q2 is the refrigerating effect produced or cooling effect produced or heat that is absorbed. We have already seen this in our energy balance, that W is equal to Q1 minus Q2, that is heat rejected minus refrigerating effect produced. Now similar to refrigerator, we are having a heat pump. It is a device which is operating in a cyclic process, will transfer the heat from body at lower temperature to the body at higher temperature, but its purpose is to increase the temperature of the source further and thus heat the space to a higher temperature than the previous one. And its performance is given by COP, again coefficient of performance or energy performance ratio. Now as the purpose is to increase the temperature of the source, here the output is heat rejected, that is Q1. Work supplied remains the same, that is Q1 minus Q2. We have already derived that COP of the heat pump is coefficient of performance of refrigerator plus 1.